Hello students, how are you today?
Fine, thank you.
Great. Welcome to mathematics class. With me I have the grade 8 students. We'll be teaching and learning a whole lot about mathematics in this lesson. And I hope that these students are looking forward to this lesson. Are you?
Yes, sir.
All right. Well, I am looking forward to this lesson even more than you. That is because, of course, I love mathematics. And I hope that for those of you who love mathematics, you will have much more fun. And those of you who do not like mathematics, you will get to love mathematics by the end of this lesson. All right? Good. The topic, the binary number system, or more simply put, the base 2 number system. This is what we'll be looking at today. But before we jump into the base 2 number system, let us review what we know about the base 10 number system. So let us just review quickly what we know about the base 10. Base 10 number system, what are the numerals we use?
0,
0,
1,
1,
2,
2, 3, 4, 5, 6, 7, 8, 9. Any other?
No, sir.
Good. These are the numerals we use in the base 10 number system. And we use these numerals to represent any number. We combine these numerals to represent any given number. So for example, we can take any 4 of these numerals. We can take 4, 5, 7, 2, and we form a number which we call 4,572. So this is how we use the numerals in base 10. In a similar way, we use numerals in any other base. But since we're looking at the base 2 number system, we may want to look at what are the numerals we use in base 2. So the numerals used are 0 and 1. Yes, for the base 2. Just as with the base 10, we use from 0 all the way up to 9. If it is base 8, we will use from 0 all the way up to 7. Base 5, we go from 0 to 4. Since it is base 2, we're going from 0 to 1. Good. So 0 and 1. So it therefore means all numbers in base 2 must be formed using these numerals, 0 and 1. So for example, we can make a number by combining zeros and ones. So we may have 1, 1, 0, 1, 0, 0, 0, 1, 1. This is a number in base 2. However, we may have a confusion because someone looking at this number here might not know that it is a number written in base 2. They might think that this is a number written in the normal base 10 system. All right? And somebody might want to say, oh, this is 110,100,011. So to help us to differentiate between the various number systems, we use subscripts for all number bases that are not base 10. If the number is base 10, we do not use any subscript. Like when we did positive and negative numbers, if it is positive, we use no sign. But if it is negative, we do. So if it is base 10, so for example, if you have 76, there is no need for a subscript. But if it is any other base, for example, base 2, well then we use the subscript to indicate which base this number is written in. So this number here now, we can say clearly that this is a number written in base 2. Is that clear? So having base 2, these numerals, we must find a way of rewriting all the numerals that we use in base 10. And the numerals we use in base 10 are from 0 to 9. So I'm just going to show you how we can write the numerals for base 10. And we have base 2. So base 10, the numeral 0 is the same as 0 base 2. Then for 1, we have the same as 1. Then we have the numeral 2, which is written as 1, 0. And somebody might be wondering, what is happening here? All right? These are all base 2. Then we have the number 3, which is written as 1, 1. We have the number 4, which is written as 1, 0, 0. We have the number 5. We have the number 6. We have the number 7, the number 8. And we can go on to the number 9. And the number 9 is written as 1, 0, 0, 1, base 2. So there are ways of writing each base 10 number, or these numerals in base 10, as a numeral in base 2. So somebody wants to know, how did I do this? How do I know that 4 is equal to 100 base 2, or 9 is equal to 1001 base 2? But you won't have to worry for too long, because by the time we complete this topic, base 2, which will be for this lesson and the next lesson, by the time we complete this topic, you will master how we change from base 10 number over to the base 2 number. But we will take this for now. So anytime you see this, we know we're referring to the number 4. We will look next at the place value. When you hear place value, what comes to mind? Place value. For example, we'll be talking about the place value of units. Then we have tens, hundreds, thousands, tens of thousands, and we can keep going on like that. So we talk about place value. So we can speak about the place value for the base 10, but then we will also want to look at the place value for base 2, because if we're going to use numbers in base 2, we need to know what are the place values for numbers in base 2. Are you curious about that? What are the place values for numbers in base 2? Yeah, because if we're going to use any base, we must know how to write the place value. So let us first write the place values for partial place values for the base 10 system. And then we're going to compare it to the base 2. Yes, let us look at the base 10 place value. We're going to look at the place value grid for base 10. Now we can start with, if you have 10 to the 0 power, we know that the units, ones, can be written as 10 to the 0 power, because anything to the 0 power is 1. Then we can look at tens, the tens place value. Tens will be the same as 10 to the first power. Then we can look at hundreds. 100 is the same as 10 times 10, which is 10 to the second. And we can follow this pattern and we can continue. We can look at thousands, which is 10 to the third. And then we can go on to 10,000 or tens of thousands, which is 10 to the fourth. And then we can go on to 10 to the fifth. So we see with the base 10, the place values are just powers of 10. So if we want to find the place values of 2, well then we also need to list it according to the powers of which number?
2.
2. Yes, according to the powers of 2. So let us set up our table for the place value. Place value for base 2. So we will start with, as always, 1, which is 2 to the 0. Which will be the next place value?
10.
We're dealing with base 2.
2 to the first.
2 to the first, which is 2 itself. Just remember how we were going. When it is base 10, we were going 1, 110, 100, so we were multiplying by 10 all the way. So we start with 1, this is base 2 now. So we start with 1 and it will be 2 ones 2. What will be the next one?
2
2 twos 4, which is the same as 2 to the second power. Then we have 4 twos, 8, which is 2 to the third. Then we have 8 twos, 16, which is 2 to the fourth. 16 twos, 2 to the fifth. And 32 twos, 64, which is 2 to the sixth. But of course, we can keep going on. All right, we don't have to stop here. We can keep going on. So this is how we identify the place value in the base 2 system. So now we're going to look at the base 2 numbers, and we're going to see how we can express a base 2 number, a number which is written in base 2, or a number which is written in base 10 as a base 2 number. We're going to try to represent the base 10 number as a base 2 number. To help us to do this, we're going to start by using the place value grid. So I'm going to set at the top here the place value grid. So we have 2 to the 0, 2 to the first, second, fourth, fifth, sixth. We will see how this grid will help us to express a base 10 number in base 2. Okay, let us look at a set of numbers which we will change from base 10 into base 2. The first number we will express is the number 12. Now what we will do in order to change this using this grid here is to see what combination of these place values will give us 12. Can anyone identify what combinations will give us 12? Should we add 64 and 32 to give us 12? We have all of these here. What combination will give us 12? Who will answer? 8 and 4. So we say that we need 1 8 and we need 1 4. Do we need any 2? No. Do we need any 1? No. Good. So then we can say that the number 12, if I list them at the corner here, the number 12 in base 10 can be written as 1100 in base 2. And that's how we can easily change from base 10 to base 2. Good. What about the number 18? The number 18. What combinations will give us 18?
16 and 2.
So 18, we are taking a 16, no 8, no 4, a 2, and no 0. So this is how we write 16 in base. Sorry, this is how we write 18 in base 2. Let us consider another number. We can consider the number 48. Let's consider number 48 now. 48 can be written as 32 and 16. So we have 48, which is 132, and we have a 16. 32 and 16 will give us 48. Good. Any question from anyone on how we do this? So you tell me now 88. What combination? I think definitely we have to get a 64, huh?
Yeah.
But if we take 32, that's going to go past 88 because 60 and 30 is 90. So that will go past. So we take a 64, but we can't take 32. 64 and 16 will give us 80. And then we can take an 8. Then we can't take anything else. I think that will take us to 88 there straight away. So it's a 64, a 16, and an 8. So we can say 88 in base 10 is written as 1011000 in base 2. And this is a way, if you have a table like this, you can easily convert from base 10 into base 2. But then we do not always have a table. And if you have, every time you have to convert from base 10 to base 2, if every time you have to be constructing this table, it's going to be using up too much of your time. And as mathematicians, we always try to use less time to solve our problems. So I do not want to know every time you have a problem to solve, you have to go setting up this table. So we will look at an alternative approach, whereby if you have one number, you don't need to set up this entire table, but we just use a process of repeated division. Okay? When we just keep on dividing with whatever the base is. So let us explore that particular process. So converting base 10 numbers to base 2. Let us start with the number 12. We're going to use those same examples which we used just now. Let us start with the number 12. To convert, we set up a table which we divide with. We will have the number which we are converting. Then we have the remainder when this number is divided by the base we are converting it to. So the number we're dividing and the remainder when we divide by the base we are converting to. And we start dividing and we list coming down. So we say 2 into 12,
6.
remainder,
0.
0. Good. Then we go again. 2 into 6,
3.
remainder,
0.
good, because 2, 3, 6. 2 into 3,
1.
remainder,
1.
correct. And then 2 into 1, 0, and remainder 1. So we have nothing else to divide. So our answer is staring us straight in the face there. So just for us to pick up what our answer is. To get our answer, we use only the remainders in a particular order. Can someone say what is that order? From the bottom going up. So we list the numbers in this order. So we say that 12 will be equal to 1, 1, 0, 0, base 2. It is important for us to put in our subscript 2. Now, I know you will want to check to see how well you understood that first example by attempting to convert 18 in a similar way. How do we convert 18 in this approach to base 2? Harriet, you seem to have an answer. What is your answer?
10010 base 2.
10010 base 2. Now, this is the answer which Harish is giving. So we will check to see whether Harish is correct. Anyone else found the answer? Found an answer? You have the same thing. Zephaniah has the same answer as Harish. Anyone else? So then, let us check to see what 18 is in base 2 using this approach here. Now, what you will observe is that whichever of the two approaches you use, you will get the same answer. But it's just that sometimes this approach is a much faster one. So the base is 2 and we're converting 18, so we list our remainder. So we say that 2 into 18, remainder, 2 into 9, 2 4s 8 and 1 remainder, 2 into 4, 2 and no remainder, 2 into 2, 1 and no remainder, 2 into 1, 0 and 1 remainder. And we list the numbers from bottom going up. And is it the same number as Harish provided?
Yes, sir.
Yes, it's the same number that Harish provided. Let us consider one last example. And we're going to look at the number 29. How do we convert 29 to base 2? Someone is providing an answer?
Yes, sir.
What is 29 equal to?
11101.
11101
Base
base 2. Alright, we have two persons saying 11101 base 2. Let us check and verify whether this is so. 2 into 29? 14 and 42 is 28 and 1 remainder. 2 into 14? 2 sevens 14, no remainder. 2 into 7?
3.
2 3 6 and 1 give us 7. 2 into 3?
1.
2 ones 2 and 1 give us 3. 2 into 1?
0.
0 and 1 remainder. So when we read this going from bottom to top, we get 11101 base 2, as was given before. So very much correct for those who give this as their answer. Any questions? So I hope that you now have learned how to convert from base 10 to base 2. You have two approaches that you can use. You have this approach if you just have a single number, but then you can of course use a table if you wish. If you have a whole lot of numbers which you want to convert fast, in a fast way. But I recommend that you always know to use this approach as well as the other one. Any questions? Well, let us summarize what we learned today. We looked at the base 2 or the binary number system. And we first looked at the base 10. The numerals used in base 10, and those numerals are 0 to 9. We also said that if it was base 8, it would have been 0 to 7. And we can go on like that. Since we were looking at base 2, well then the numerals are 0 and 1. So all numbers in base 2 must be written using strictly 0 and 1. Then we went on to the place values, and we recognized how for any base you can find the place values by just multiplying repeatedly by the base itself. So like in base 10 you have ones, tens, hundreds, thousands. You see you keep multiplying by tens. In base 2 you have 1, 2, 4, 8, 16. So you follow the trend there. You keep on multiplying by the base you're dealing with. And then we look at changing from base 10 into base 2. So that was our lesson for converting from base 10 to base 2 for today. And I look forward to seeing you again for our next lesson. Okay? Bye for now.